This is a talk on Cannon's point, which is one of a series of talks for colonic hydrotherapists on bowel anatomy and physiology. Who is or was Cannon? Walter Bradford Cannon is an American national. He was an eminent physiologist, born in 1871 and died actually shortly after I was born in 1954. He studied physiology at Harvard and later became professor of the Department of Physiology there. This is a picture of him posing with Ivan Pavlov, one of his elder but contemporaries, who also researched digestion. And this was actually one of Walter Cannon's first research projects, was studying digestion with the newly discovered X-rays. So rather than imagining what is happening to the soft tissue within the body, the X-rays enabled him to study real-time what was happening. He, in fact, was one of the first people to use heavy metals, including barium sulfate, to be able to image the gut, which is quite an innovation at that time and is still used now in barium enemas and barium meals. He was responsible for a lot of research during his long profession. He termed the word homeostasis to define the steady state within the body that exists so that enzyme systems work optimally. That's to regulate our temperature, our blood salts, our just about everything in warm-blooded animals, including ourselves. He also theorized the association between the sympathetic branch of the autonomic nervous system and the adrenal glands, which is actually well known. He proved during shock symptoms that it was a hormone that was released that was responsible for all the neurological events that happen, increasing pulse rate, improving blood circulation to the muscles, this sort of thing. And as a result of this, he invented or coined the term flight or fight, which is still used very much nowadays in terms of sympathetic stimulation due to shock of one sort or another. What we are actually interested in, though, is the point on the bowel, which he named Cannon's point, or was named after him as Cannon's point. So you may ask then, where and what is Cannon's point? It doesn't occur in many textbooks, so it's quite interesting to elucidate this. Cannon's point, also known as Cannon's ring, is defined as a physiological sphincter, which is a narrowing of the bowel approximately midway along the transverse colon, at which the innervation between the superior and inferior parasympathetic plexi overlap. So to put it into slightly better words, it's a division between the vagus nerve input, the 10th cranial nerve input, which feeds to the right side of the bowel, the ascending colon and the right side of the transverse, and the pelvic splanchnic nerve input, again a parasympathetic branch, which feeds to the left side of the bowel, so the left side of the transverse colon, descending sigmoid area. This is the definition of it. I prefer to think of it not as so much as a sphincter as a narrowing or stenosis of the bowel, which is more marked in some people than others, and it can be responsible for some of the things that we see during treatments. We all know during treatment that sometimes you can start and you have excellent results with people on their sides to start with, and then when you turn them onto their back, you will get the descending to empty and maybe part of the transverse, and then it can suddenly stop, and we don't know why, and you can struggle to get it going again. I often thought that this was perhaps the splenic flexure because it's a very sharp angle, but the more I work, the more I think is probably due to this Cannon's point, or the narrowing in the center of the large intestine. And of course, this point can also be surrounded by what I would term as loops of the bowel, redundant loops, so that some people who have very long bowels have these big loops that go either side. So how does this Cannon's point arise? Well, it is during fetal development. During fetal development, at a 6-week age of the fetus, 6-week term, you get a 90-degree rotation. This enables the tube that forms the gut to start to fit within the abdominal cavity. We know that guts are very long. The small intestine is 18 to 20 foot long or thereabouts, and the large bowel can be anything between 5 feet to 11 feet, depending on inheritance. So you get this 90-degree rotation at about the 6-week stage, and then at the 10-week stage you get these jejunal-ileal loops forming and a 180-degree rotation, which ends up with the bowel cecum descending down into the right side of the abdomen and the large intestine rotating up to splenic flexure. So we get the final positions, which you will recognize from most diagrams in books. Alas, there are very few bowels that are the same as diagrams. So when we work on everyone, we work on them as clients, as individuals, and the bowel is individual as well. Fortunately, it's not very easy to tell from this 2-dimensional diagram how this actually occurs, but fortunately I have a little video here which shows during fetal development how this rotation happens. So you have the tube forming within the fetus, and if I just click on this, we'll get it to rotate. And here you've got the different tissues there and the different nerve inputs, and you can see how the rotation occurs. So Cannon's point occurs between this blue section of large intestine and the purple section or mauve section of large intestine. This aligns with Cannon's point. So again, I'll just play that, and that gives a better example, a visual example of how it happens, and you can see the ileal and jejunal loops here of the small intestine. The autonomic nerve branches, you'll know these anyway. The parasympathetic branch, the 10th cranial nerve, is the one that we are mostly interested in from the bowel point of view, from the gut, but of course it feeds to all the other organs down the body as well. A very long nerve, and feeds down to the ascending colon and right side of the transverse. Whereas the sacral pudendal nerves come from the sacrum. It's also a branch of the parasympathetic and feeds, this diagram doesn't show it very well, but it feeds to the descending left side of the transverse and descending colon and sigmoid. Again, this Netter diagram, which is actually one of my favorites, shows it a little better. It demonstrates the 10th cranial nerve feeding down from the neck right the way down to the first part of the large bowel, and the sacral pudendal nerves coming from the sacral cord feeding to the left side of the transverse colon, descending colon, and sigmoid. I'll come back to this diagram later because it does show some things that we experience during treatments, and it's very interesting to note and to be able to explain what clients can experience and what can happen to clients during treatment. Here is a diagram which actually marks Cannon's point, one of the few that actually marks it in my experience, and it explains the difference between low amplitude and high amplitude muscular contractions within the bowel. The low amplitude ones are sometimes called tone waves or antiperistalsis. These are myogenic, these are muscular movements within the bowel, and they have a mixing quality. So they mix the bowel contents with the microbiome that's there. And this enables further digestion to occur, and also, of course, gas production. Classically, digestion was always thought to occur in the mouth, the stomach, and the small intestine, where absorption happens, but it's now known that up to 18% of our energy can actually be gained from digestion in the bowel by the microbiome. So that's production of short-chain fatty acids in particular, which are high energy products of fermentation. Underneath here, we have the mass peristaltic action. These are neurogenic actions. This is a propulsive movement within the large bowel, which pushes stool around and usually generates from the right side, the hepatic flexure, the right side of the transverse colon, and pushes stool around the bowel into the rectum for later defecation. As I said, this is neurogenic. Cannon's point is also the approximate border between arterial blood supply. Arterial blood supply is principally, there are two principal veins here, the superior mesenteric artery, which feeds to, again, the ascending and right side of the transverse, and inferior mesenteric artery, which feeds to the left side of the transverse, descending, sigmoid, and just short of the rectum. So this, interestingly, is also the often Cannon's point, the site of differentiation in ischemic colitis, where either one side or the other will be affected by colitis. And this is primarily due to the circulatory layout within the body. And also, the venous blood from the bowel is served again by the superior and inferior mesenteric veins, and the rough division is Cannon's point between the two. So these veins feed from the bowel to the portal system, draining deoxygenated blood. And as we know during digestion, we will know during digestion that the bowel and small intestine is richly supplied with oxygenated blood for the carrying of digested nutrients through to the portal system. And this shows it even better diagrammatically, where you've got the superior mesenteric vein feeding to the right side of the bowel, and the inferior mesenteric vein feeding to the left side. The division again is roughly Cannon's point. So, to some extent, in conclusion, what is the relevance of Cannon's point to us as colon hydrotherapists? Well, it is a physiological narrowing. So it is a very important point for massage. As I originally mentioned, you sometimes see bowel emptying during treatment stop at, I would say, approximately Cannon's point. And it can take some time to get it started again. Massage either side is really useful, and during treatments, rest periods are really useful as well. It's also, as we've said, a border between the nerve inputs. So it's the border between this low and high amplitude peristaltic action within the body. And it's the border between the superior and inferior mesenteric arteries and veins. So massage is really useful for bowel emptying, and it's particularly useful, I find, with a gravity system where you can massage when you just release the water. The distension that we provide through water does stimulate the mass peristalsis, and again, it could be something to do with Cannon's point, where it's difficult on occasion to get water round into the ascending colon to distend it enough to get the peristaltic action to happen. It could also be this mild stenosis could be contributing to keeping gas pockets trapped. And of course, in colonics, we rely very much on the hydraulic water nature of water, where if you get a column of water within the bowel, it's not compressible. So when the bowel contracts, it will push the contents out. But if you get a pocket of gas in a loop, then every time you put water into the bowel, that gas compresses. And then when you release the water, it just expands again and nothing happens. So it can be difficult to get water beyond it. So again, massage is very important. So what I would say is it's a very useful massage point. It is something that you should be aware of. And if you'll excuse the pun, I would say Cannon had a point in this. I will just return, if I may, to that previous slide. Let's have a look, see whether I can find it. Here we go. And we'll just have a look at this. It's one of my favorite Netta diagrams, this is, and it explains a lot of reflexes that you see during treatment. One of them, via the parasympathetic and via the phrenic nerve, could be contraction of diaphragm and vomiting. Fortunately, we very, very rarely see vomiting, but we can see nausea. And this, again, I'll come back to the reason why, but it is overstimulation, overtreatment, perhaps using water that's too cold so it overstimulates the bowel, or even too much massage. Massage should be gentle in some people, certainly. Perhaps, though, the more interesting reflexes are these here via the sympathetic branches. And this would correspond largely to vasovagal episodes, which we can see. Viscerosensory, this is hyperalgesia, so sensitivity of the skin in the corresponding dermatome. Segmental sweating, we sometimes people see, rarely, but we sometimes see people go quiet and a bit pale and sweaty. Segmental vasodilation, viscerovascular, so warmth of skin, dermographism, blotchiness on the skin. Visceromuscular, this is particularly goose flesh, erection of the pilomotor muscles, so they'll go a bit goose fleshy. And visceral, which is, we see the results going through the tube here, of altered motility and tonus of the organs in the corresponding related segments, spinal segments feeding to the various parts of the bowel. So you will often get a big release during this time, or even a big release can cause this vasovagal episode. What to do during this? There's only one thing to do: stop the water running, don't massage, get the people to take nice deep breaths, get them to relax. It always passes, it always passes. Reassure them. It's also very useful sometimes to send them off to the loo, as long as it's safe to do so, where gravity can play a part, especially if you have a reasonable amount of water in the bowel. And finally, via the parasympathetic pelvic splanchnic nerves here, the sacral branch, you get altered motility in the viscera of other spinal segments. And this we will know principally as the gastrocolic reflex, which is the one that's often responsible for giving the bowel movement first thing in the day, which is when you wake up, you have the, what's it called? Well, when you have breakfast, you have the gastrocolic reflex, and that adds to the orthocolic reflex. That's when you wake up and things start to move in the body. These two produce the maximum mass peristalsis in the lower bowel. So this is the time when a fecal bolus will get sent into the rectum and you will get the sensation to go to the loo. This explains also why some people, when they have a big meal, the larger meal you have, the greater is the gastrocolic reflex. Some people, I would say particularly males, are driven to get up to defecate during a meal or immediately afterwards as well. So there are good neurological reasons for these reactions. So I hope you found this talk to be interesting, and I look forward to giving a few more.